Welcome to the Central Instrumentation Facility at Birla Institute of Technology, Mesra. Located in the serene campus of BIT Mesra, our Central Instrumentation Facility is a vibrant hub where students, researchers, and faculty members come together to push the boundaries of knowledge and make remarkable discoveries. CIF is divided into 7 sections, namely Advanced Microscopy, Chromatography, Spectroscopy, Thermal Analysis, Mechanical and Rheological Analysis, Water Analysis, and X-ray Diffraction. Today we have something truly exciting to share with you. We're taking you on a virtual tour of the Central Instrumentation Facility at Birla Institute of Technology, Ranchi.
Specialized instruments for spectroscopy and thermal analysis, all present under one roof and is functional since year 2006.
Let me present you to the various thermal analysis instruments.
TGA measures weight or mass change as a function of time, temperature, and atmosphere. It determines the composition of materials and predicts their thermal stability. It involves subjecting a sample to a controlled temperature, increase or decrease while continuously monitoring its weight. There are 2 crucibles, one for sample and the other one is reference, which is kept in a furnace for controlled heating.
This is a modulated DSC. Its make model is DSC 25 by TA Instruments USA. This DSC measures the specific heat capacity and phase transition of various material. The purge gas condition, heating rate, and starting and end temperature are the important parameters for this instrument. This modulated DSC is especially designed to measure the crystallization, oxidation, melting, glass transition, and the percent crystallization of various material. Instruments can be operated both manually and automatically. Now we will be introducing the spectroscopic instruments. This is a Fourier transform infrared spectroscopy machine for mid-near and far IR regions. Its make module is Perkin-Elmer USA. The fundamental principle behind FTIR involves the interactions of IR radiation with the molecules in a sample. Molecules have specific vibrational modes that can absorb infrared light at characteristic frequencies, resulting in the excitation of these vibrational modes. FTIR is used to detect functional groups, chemical composition, and impurities. Any solid liquid sample can be analyzed in this instrument. Here we keep the sample on the germanium crystal and the probe detects the sample. Various peaks are observed on the result obtained. This is the zeta Sizer nanoparticle characterization system. This capillary and DLS cuvette are the major components of this instrument. This instrument is used to measure and analyze the size of a particle in a colloidal solution on the basis of dynamic light scattering. The principle behind the zeta potential measurement involves the application of an electric field to the particles or molecule suspension in the subsequent observation of the movement of the particle under this field.
Hello everyone, I am Vidutulata.
I am Purnima.
We are in CIF at BIT Mesra.
Now we are here in water analysis laboratory. So let's have a look. This instrument is pH meter. The model we are using here or Thermo Orion USA, and pH meter is scientific instrument used for the analysis of alkalinity and acidity of solution, and it is used to determine the concentration of hydrogen H+ ions in solution.
The This instrument name is Digital Reactor Block Analyzer DRB200. It is used for digestion for metal analysis, digestion for nutrient analysis, or culture biological sample.
This instrument is microwave reaction system by Anton Bar Company. It is used to dissolve heavy metals in presence of organic molecules for analysis with various methods. And this is a vacuum pump which is used to release gases.
This instrument name is colorimeter, made by Hatch. It is a light sensing device which is used to measure the absorbance and transmission of light as it moves through a sample of liquid. These are the two parts of a colorimeter to boil off. One is used for blank and second is used for sample.
Instrument name is ICP-OES, inductively coupled plasma optical emission spectrometer. The model where we use Optima 2100 dB and the company is Perkin L1. And this machine is used to determine how much elements are present in sample. Mostly water is dissolved, and its principle the fact that atoms or ions which absorb energy from lower state to higher state. Let's talk about here. Two gases are connected with. The gases are nitrogen and argon, and here we will see that the parts of this machine. The first part is nebulizer, you can see here, and the second part is your plasma, and the third part is spectrophotometer. Here you can see that this is a chiller part and this is a vacuum pump. Which both are connected with the software and the machine is connected with software, and here the software we are using is Rheolab 32 ICP continuous.
This instrument name is ICP-MS, inductively coupled plasma mass spectrometer. This instrument made by Thermoscientific in USA. The model name is ICFP-RQ. It can be used to measure element in trace level in biological sample. ICP-MS uses in argon plasma. The ICP convert to the sample into ions that then measured using a mass spectrometer. This instrument is auto sampler. This is a peristaltic pump. This is argon plasma. This is chiller, and the software is the software name is Chromatography.
Welcome to Separation Science HPTLC setup by Cambridge company, Switzerland, and the components are first of all this is nitrogen cylinder, then applicator, software by Vision Cat, development chamber, then scanner, then TLC visualizer, and derivatizer. This is based on thin layer paper chromatics application, identification and quantification of natural compound. And
here is the HPTLC-MS interface by CAMIG Switzerland. When connected to an HPLC pump, allows for the efficient transfer of analytes from HPTLC plates to a mass spectrometer. This integration combines the separation capabilities of HPTLC with the identification capabilities of MS. The HPLC pump facilitates the elution of analytes from the plate, enabling their analysis in the mass spectrometer. This setup is advantageous for applications such as natural product analysis, forensic analysis, pharmaceutical analysis, and environmental analysis, providing enhanced separation and structural information for complex samples.
Analytical HPLC, High Performance Liquid Chromatography. It is a thermoscientific US-based company, HPLC, and its model is Vanquish. Its various components are: this is the solvent rack, this is the detector, auto sampler, pump, and the column compartment with C18 column. And it is run by the software Chromeleon 7.2 version. HPLC is based on the principle of separation of compounds on the basis of stationary and mobile phase. So the stationary phase used in HPLC is C18 column, and the mobile phase used are acetonitrile, water and methanol. That is all MS grade, and its application is in the various pharmaceutical and forensic science departments for the fractionation of natural compounds.
The LCMS Ultimate 3000 LTQ-XL from Thermo Scientific is a high-performance liquid chromatography mass spectrometry LCMS system equipped with an electrospray ionization ESI technique. It combines the separation capabilities of liquid chromatography LC with the sensitive and selective detection of mass spectrometry MS. The ESI technique allows for the ionization of analytes in the liquid phase, generating charged ions that can be detected by the mass spectrometer. This system offers excellent sensitivity, resolution, and mass accuracy, making it suitable for a wide range of applications in areas such as pharmaceuticals, environmental analysis, metabolomics, and proteomics. It enables the identification, quantification, and structural elucidation of complex mixtures and biomolecules.
This is a flash column chromatography, and it is manufactured by the company Bona Agila Technologies company, and its model is Cheetah MP200. It is run by the software Agila Technologies. Here the principle is basically it is based on the separation of compounds on the basis of stationary and mobile phase, but here compressed air is used that puts the pressure on the columns for acceleration of the elution of the mobile phase. So it is better to isolate chemical compounds or crude chemical compounds.
Anton-Par rheometers are advanced instruments used for measuring the rheological properties of materials. They provide precise control of shear rate, temperature, and applied stress, allowing for the characterization of viscoelastic behavior and flow properties in various industries, including cosmetics, food, and pharmaceuticals.
To rheometer, we can measure viscosity and flow behavior of material with respect to shear stress, shear modulus, and deformation conditions. These applications of rheometer make it widely popular in the domains of pharmaceuticals, medicals, polymer processing, R&D, and etc.
Anton-Par BT surface area analyzers employ gas adsorption techniques to accurately measure the specific surface area of solids using the Brunauer-Emmett-Teller (BET) method. These analyzers are essential for characterizing catalysts, powders, and porous materials in research, development, and manufacturing industries, providing.
The instrument here is the Universal Testing Machine, also called as UTM, and the model that we have is Instron 8801. Its applications include tensile testing, compression testing, bend testing, and field testing. It comprises of an upper jaw face and lower jaw face wherein the sample is placed in the middle, and with the help of the load cell the required force is applied. It also has a remote controller for the easy movement of the upper jaw face and lower jaw face. The flame control panel here also helps with the movement. This instrument also has an emergency stop button. The software that we used for this instrument is the Blue Hills software. This is the multi-tribometer, and the model that we have here is the Ducom TR705.
Two types of test can be performed. One is LRT and other is pin on desk, and both can be done by using their respective softwares. This is the single crystal XRD form brand Rheological, which is from Japan, and the model is Excalibur Gemini. So as we can see here, the diffractometer and CCD detector are mounted inside the cabinet. So let me quickly introduce the parts that are located inside the single crystal XRD. This is our X-ray tube, which is mounted on the goniometer, and it is powered by high voltage X-ray generators. This is our collimator. The target metal is molybdenum here. This is our CCD detector. This is the sample holder where we place our sample. has 4 axes of rotations, which we call 4-axis kappa goniometer, and the axes are phi, kappa, omega, theta. This is the video microscope which captures the footage and displays directly to the computer through the software called Alice Pro software. Single crystal XRD is a powerful technique used for the analysis of single crystal. Thus, it becomes very much useful in determination of crystal and its lattice structure. And this is how the result looks like. A powder X-ray diffractometer is from Rheological and model is MATLAB. It has 2 theta angle 3 degree to 120 degrees and the powers are 3 kW and 9 kW. The target metal used here is copper. This is the sample holder. This is Hypix 7000 and SC7. This is the X-ray tube from where X-ray comes out. The target metal is copper here, which produces the wavelength of 1.7 angstrom. And this is how our data looks in PDXL software.
Hello everyone, myself Baisha Baisakhi
and myself Basudev Prakash,
and we welcome you all to the Advanced Microscopy section
of CIF BIT Mesra.
So this machine in front of you is known as Scanning Electron Microscope, also called SEM. The make of this instrument is Rheological, Japan. The model is JSM 6390LB. Few specification of this instrument is the resolution from 3 nanometers at high vacuum mode and 4 nanometers in low vacuum mode and 30 kV accelerating voltage. The magnification of this instrument can go from 5 to 3 lakhs times. The image mode present here are the secondary electrons and the backscattered images. The major application of this instrument is surface morphology, compositional analysis and topographical analysis.
Now I am going to tell you about the working principle of this machine. The machine works on the principle of electron interaction with matter and the images are taken from the electrons backscattered from the sample. This part of the machine is the thermal gun from which the electrons are generated, and this is the column from which the electrons travel to the sample. In this part there are various lenses like condenser and scan coils which focuses the electrons. This is the aperture and these two are the various parts from which the images are detected. The machine has 5 axes of rotations which are X, Y and Z, R and T which are the axes of rotation and tilt respectively. These are the 2 rotary pumps which can achieve a vacuum of 10 to the power minus 3 millibar. Usually the sample should be conducting for SEM, but if the sample is non-conductive, we use to coat the sample using this machine which uses the principle of sputtering, and the images are taken like this. Now we will show you the working of atomic force microscope. This machine is a make of NTMDT Russia and has a model of Super Pro 47. The specification of this machine is scanning by sample and has a resolution of the atomic scale. It has a SPM controller system and has various modes of measurements which are contact, non-contact, semi-contact, tapping and STM modes. The application of these machines is for surface morphological studies, topographical texture, magnetic and adhesive force related studies. Here is one of the images which we captured during our internship period.
So I am going to tell you the basic working principle of AFM, which is governed by Hooke's law. Here there is a nanoscale tip present on the cantilever that basically works as a spring. As soon as the cantilever moves on the surface of the sample, there is certain movement which are governed by various forces such as electrostatic force, magnetic force, capillary force, van der Waals force, etc. As there is movement, this movement is captured by a laser diode and a split photodetector. This interactive signal between the tip and the surface of the sample is then sent to the feedback controller that is attached to the software, and this helps to map the surface at various nanoscale ranges. So our last machine is FESM, also known as Field Emission Scanning Electron Microscope. The one you're seeing is the make is from Carl Zeiss, Germany. The model is Sigma 300. The major specification of this instrument is the resolution, which is approximately equal to 3 nanometer. The magnification can go from 25 till 12 lakhs, and the application is similar to SCM, that is surface morphology, composition analysis, topographical analysis. But another one, that is the elemental analysis, to know the different kind of elements or the element mapping in a sample can be done.
The working principle of this machine is same as SEM, that is the electron interaction with matter. The various parts of this machine include, this is the FEG gun, and this is the columns where the various scan coils and condenser lens and aperture are present. This is the R detector for backscattered electrons. This is R detector for in-lens, and this is the detector for EDX, which is used for elemental analysis and mapping. This detector is for difference between SEM and FESEM are as follows. Here there is a FEG gun instead of thermal gun. Also, the gun and the chiller remains on for 24 hours, and as you can see in the images is of higher resolution and the magnification is higher compared to SEM.
CIF BIT Mesra offers sample testing facilities to research and development, industry, and academic organizations on nominal charge basis. Testing charges can be calculated using charge calculator available on the CIF webpage of BIT Mesra website.
I'm really grateful to CIF BIT Mesra for giving me this opportunity, and also I'm really thankful to my coordinators for giving me the hands-on training on mechanical and rheological analysis and letting me learn some of the major skills.
I'm very thankful to the CIF department of BIT Mesra Ranchi for providing me hands-on experience on the instruments used in spectroscopy, and I am very excited to use it in my future endeavors.
I am satisfied with the training course provided by the campus. I am also very thankful to the CIF faculty members.
I am very thankful to BIT Mesra Ranchi for giving me opportunity to handle workshop. I think an internship program is very helpful to students.
Sure. This was my first internship and I liked it very much. I very much like to explore the fields of rheology and tribology. These topics were new for me, and I am very much thankful to all the CIF members that I have explored such new fields.
Hello, I'm Varsha, and I'm very thankful for joining over this internship program, because doing this gave me a lot of experience in the field of microscopy, which I have selected as my section of work. And during the study, I was allowed to do the analysis very independently.
I have learned a lot about instrument and its principle. I'm thankful to the CIF lab at BIT Mesra who gave an opportunity to work and experience.
I am very grateful to CIF and my coordinators for giving me this opportunity. The new knowledge and the skills learned during this process will definitely help in my future endeavors.
I am truly thankful for the valuable experience and learning opportunities which I have gained here during my time period summer internship program CIF in BIT Mesra.
Very first time where I get hands-on experience on several machines, and for this I would really like to thank CIF.
I'm very thankful to CIF BIT Mesra for providing me the opportunity to be the part of this summer internship. The techniques and instruments that I have learned here would help me further in my PhD and future research endeavors, and I am looking forward for such trainings in future.